Solve the system of inequalities in two variables. The solution to a system of inequalities is going to be the shaded region that satisfies all four of these inequalities. To begin, let's start with these two inequalities, and we'll notice that x is equal to 0 is the y-axis, and y is equal to 0 is the x-axis. So this would be the line y is equal to 0, and this is the line x is equal to 0. So to satisfy this inequality, we would want the x values that are to the right of the y-axis, the x values that are positive, and to solve this inequality, we would want the y values that are above the x-axis. So when we have these two inequalities, we know that our solution region has to be in the first quadrant. And so we'll focus in the first quadrant when we're solving these other two inequalities. We'll start with 3x plus 5y is less than or equal to 45. And we'll proceed as if this inequality were an equal sign, meaning that we'll solve for y to get it in slope-intercept form. I'm actually going to leave the inequality symbol in it instead of changing it to an equal sign, but you can change it to an equal sign and then use a test point to determine the solution region if that feels easier. So subtracting 3x from both sides, we get 5y. Again, I'm keeping the inequality symbol this time, and we have 3x plus 45 on the other side. And then we divide both sides by 5 to get y is less than or equal to negative 3/5 x plus 45 divided by 5 is 9. So the y-intercept will be at 0, 9, and the slope of this line will be negative 3/5. Because it's less than or equal to, we're going to graph this using a solid line. And I'm going to clean up this first quadrant here just a bit, but we do know that whatever our solution region is, it must be in the first quadrant. So starting at 0, 9, and I'm going to go down 3 and right 5, which will put me at the ordered pair 5, 6, and then we go down 3 and right 5 again, which gives us the ordered pair 2, 11. Now we connect these dots with a solid line, and since we actually kept the inequality through our calculation, we can intuit which region is going to be shaded instead of using a test point. If we had an equal to sign right here, this would be the equation of the line itself. But we want the y values that are less than the line, which means that we're going to want to shade below the line. However, we could also choose a test point. I'm going to choose 5, 1 to make the calculation a little bit easier, and then plug it back into the inequality to see whether or not we're going to shade the region that contains our test point. If we plugged 1 in for y and 5 in for x, we need to decide if 1 is going to be less than or equal to this negative 3 plus 9, and this is a true statement, so we would be shading the region that is below the line. So now we know where the solution to this inequality is. Let's now find the solution to the last inequality. I'm going to leave the inequality symbol in the computation again, instead of actually changing it to an equal sign. We'll solve it for y by subtracting 6x from both sides to get that y is greater than or equal to negative 6x plus 6. So we see we have a y-intercept at 0, 6 and a slope of negative 6. So we'll start here at the ordered pair 0, 6 and go down 6 and right 1 to land at the ordered pair 1, 0. Now we'll connect these two dots with a solid line. And because we want the y values that are greater than or equal to negative 6x plus 6, this time we're going to be shading above this line. Again, we could choose a test point if that feels easier, but if we leave the inequality in the computation, it becomes a little more intuitive which direction we should be shading. So the solution to this entire system is going to be the region in the first quadrant that is below the black line and above the purplish line. And that would be this shaded region right here.